Hi there, welcome back to my channel. So in this video, I'll be taking you through counting range. So we have problems in digital systems where they'll ask you to find a range of decimal values that can be represented by a certain number of what bits, right? Then sometimes you'll be given the range and you'll be asked the number of bits which you can use to represent that particular decimal number. Okay. So I have some two problems here to illustrate this to you. Okay. Now let's see. It says, what is the total range of decimal values that can be represented in 8 bits? So let's take the first part. What is the total range of decimal values, right? That can be represented in 8 bits. So we want decimal values that can be represented in what? 8 bits, okay? So to get that, we have a general formula saying that the range of values will be 2 to the power n minus 1, okay? 2 to the power n minus 1, where n here is the number of bits given, okay? So simply put this inside our formula, 2 to the power 8 minus 1. So what is 2 to the power 8? You just take your calculator, right? You punch 2 to the power 8 and we get in 256, right? So 256 minus 1, which is giving us 255. So you say that the range of decimal values, you simply write your range. Okay, range of decimal values is simply going to give us 0 to 255. Okay, so this is how we go by the range of decimal values problem. Let's see the second part of the problem. It says, how many bits are needed to represent decimal values ranging from 0 to 12,500? So in this case, we've been given the number of what? The range of values, but we need the number of bits. It's still the same as the formula here, right? So this formula here is used to what? Represent the range. Is that not it? It's used to represent the range. So to get this, you say 2 to the power n minus 1, which is the range, is now giving us what? 0 to what? 12,500, right? So 12,500. So let's say 0 to 12,500. Is that not it? So let's see something here. So whenever you have a range 0 to 12,500, meaning that once you subtract 1 from this figure, 2 to the power n, that is when you would say that it is 0 to what? 256. You get it? There are 256 numbers, all right, but when you introduce the range inside, you realize that we simply deduct 1 from what? Our total number. Then we say that we are starting from 0 to 255. So with this one, I can simply add 1 to my number and I'll have 2 to the power n to be equal to 12,500 and what? 1, right? So meaning that what n will give us this expression here. Okay, so in microprocessors, you see, we normally use multiples of 2. Multiples of 2. So 2, 4, 6, 8, 12, 14, 16, and the rest. That is the right evolution for the numbers we use for the microprocessors. So normally we try to get n which are also in powers of 2 and all that. But for this one, the first thing to do is, this is maybe going to take logarithm on both sides, but we don't need any decimal numbers. So we need a whole integer. We need an integer. Okay, we need an integer to represent our n, right? And it should be positive integer to positive integer. So for that reason, we cannot use logarithm unless you get a decimal value. So you simply start guessing. So here you can guess. You know that 2 to the power 10 is 1024, right? That is what we call kilo, right? So we don't want that one. So you can say 2 to the power 13. So 2 to the power 13. What is 2 to the power 13? So 2 to the power 13 is simply giving us 819. 8192. Okay, so this number is far less than what? It's far less than 12,500. Then you can try 2 to the power 14. So 2 to the power 14 is giving us 2 to the power 14 16,000. You are getting 16,384, which is also far greater than what? Our 12,500. So therefore, what you do is, instead of us choosing a number which is far less than, we can choose a number which we can get what? Arrays. So here we say that our n is what? Equal to 14. This is because when you take 14, 16,000, we can get what? 12,500 within it, because we need the number of what? Bits that can really what? Cover all. So that necessarily means that it should be equal. Okay, we can get unused spaces, but we still want the what? Maximum. So that is 14. So take note. So this is the end of this section. Don't forget to like, subscribe, and share.